Hello everyone. Suppose the road in the previous problem has a mass of 1 kilogram distributed uniformly over its length. Find the initial angular acceleration of the road and find the tension in the support to the block of mass 2 kilogram and 5 kilogram. So look at the diagram here. The first question is asking for the angular acceleration. So we can calculate here the net torque acting on the system is equal to the net moment of inertia into angular acceleration. So angular acceleration alpha is equal to the net torque divided by the moment of inertia net value. So the net torque can be calculated here. So net torque is equal to the moment due to 5 kilogram is greater than the moment due to the 2 kilogram. So we can write here 5 kilogram into g, mg into perpendicular distance. What was the perpendicular distance here? In this one, this is the perpendicular distance. So L by 2. So we can write the 5g into L by 2. That is here L is already given it's a 1 meter in the previous problem. So it become what? 1 by 2 minus now the moment due to 2 kilogram. So we can write here 2 into g, mg into perpendicular distance from the pivot, that is also equal to L by 2. So 2 into g into L by 2, once again length of the road is 1, so it become what? 1 by 2. So what is the net torque we are getting here? If I take the g equal to 10, so the answer become 50 by 2, which is equal to 25, minus 20 by 2, which is equal to 10, that is net torque is equal to 15 Newton meter. So this is the net torque acting. Now you have to calculate the moment of inertia. What is the moment of inertia formula? Moment of inertia is equal to mass into distance square. Mass into distance square. But here, what is the total moment of inertia is asking for? So total moment of inertia is equal to moment of inertia due to this 5 kilogram block. So what we can write here? 5 into distance square. What is the distance square here? Distance is equal to L by 2. The L by 2 whole square. Once again length is equal to 1 meter. So it become, we can write the L by 2 the whole square. Next one, the moment of inertia due to 2 kilogram. That is equal to what? 2 into distance square. Once again L by 2 whole square. L is equal to 1 meter. So it become 1 by 2 whole square. Next one, it is given there in the question, 1 kilogram is distributed uniformly over its length. So we can write here, when the mass is distributed over its length, it's just like we can consider as a thin road. A thin road, and the axis of rotation is what? About it's exactly at the midpoint. So when a thin rod is rotating about its center, the moment of inertia we have already learned about ml square divided by 12. So we can substitute here 1 kilogram mass is distributed over its length. So 1 into length is equal to once again 1 meter, that is equal to 1 square divided by 12. So if you substitute this value, we will be getting I net is equal to 5 by 4 plus 2 by 4 plus 1 by 12. So you will be getting here what? 7 by 4 plus 1 by 12, which is equal to 88 divided by 48. So what is the answer? First one, angular acceleration alpha. You can substitute here. Alpha is equal to tau net. What is a tau net? 15 Newton meter divided by 88 divided by 48. That is the moment of inertia net value. So it become into 48. If you calculate this value, you will be getting approximately the alpha is equal to 8.18 rad per second square. So this is the first answer. Now look at the second question now. Find the tension in the support to the block of mass 2 kilogram and 5 kilogram. So let's do the second part of this question here. So if you draw the free body diagram for the 5 kilogram block, look at the 5 kilogram block here. The 5 kilogram block, the mg is acting vertically downward. Okay, mg is acting vertically downward, and the tension is acting vertically upward, and the 5 kilogram block is now coming downward. So we can say that it is accelerating downward. So what is the formula here? We can write mg minus mg minus tension is equal to m into a. So we can write here what is mg, 5g. 5g stand for, we are taking this at 10 approximately, so 50 minus tension is equal to 5 into acceleration, but we don't know the acceleration, right? So we can write here linear acceleration a is equal to r alpha. We have already learned that formula. A is equal to, what is the r value? The distance from the pivot, from the axis of rotation, that is equal to what? 1 by 2. Alpha we have already calculated here, we can take approximately 8.2. So what is the acceleration is equal to 4.1 meter per second square. If you substitute this value, we can calculate here 50 minus 5 into 4.1, that is 5 into 4.1. What is the value become? 20.5, which is equal to tension. So what is the tension acting on 5 kilogram block, which is equal to 50 minus 20.5, that is approximately 29.5 Newton. The same way, you can also calculate the tension acting on the 2 kilogram block. Look at the diagram here. Once again, tension is acting upward and 2 kilogram mg will be acting downward. 2g, mg is equal to 2g, tension is acting. Now what is the acceleration here? Acceleration is now upward. Right, so we can substitute the value here. We can write the tension minus mg, which is equal to mass into acceleration. What is the mass here? 2. So we can write the 2 into a. Therefore t is equal to, what is equation become? 2 into g plus a, that is 2 into g, we are taking it as a 10, plus acceleration is 4.1, that is equal to 10 plus 4.1, 14.1, which is equal to approximately 28.2 Newton. I hope you understood this one. Thank you.